Hi, this is Martin from Playcraft. I wanted to do a quick video on how input is handled inside the engine because there's been a few questions on that one, and it is a little bit of a concept to get, as well as how input is handled in the basics, as well as handling input as components that you add to entities. And we just made some changes in 0.5.3 with some updates to that around handling touch controls and handling mouse controls, and I'll get into explaining how that works as well. So probably the first demo to look at is Asteroids. If you've seen the Asteroids demo, it handles input, which is pretty basic and pretty standard to what you would need in a simple game. I'm using the arrow keys to drive the little ship around, fire. That's about the only controls. So if we pause this and go take a look at the code in the Asteroids demo here, I'm using WebStorm. If anybody's looking for a great IDE, I really recommend WebStorm. So the input for the Asteroids demo is set up, let's just have a look at this, in the game scene. And then inside the init of the game scene, down the bottom you'll see where it sets up the controls. Now this is the most direct way you can do it. And the basics of how this works is that you ask the global device input handler to bind a state, and in this case it's the turning right state to the D key, and you'll notice that the turning right state is also bound to the right arrow key as well. So this is one of the first concepts to get, that you bind a particular input, of which there can be many, like the right arrow key, or touching a particular thing on the screen, or the D key, and you bind those things to this abstract representation of what your object in the game should do. So in this case it's turning right. You can see all the other actions here: turning right, turning left, thrusting, reversing, firing, and there was a couple of keys for toggling debug and turning the music on and off. So the next thing you notice is that there's both states and actions. And the biggest way to think about the difference here is that a state is something that is either on or off, like I am currently turning, I'm in the turning state, and an action is something that happens as soon as the event occurs for the input. And if you're handling a state, typically that's something that is going to happen whilst the input's in progress. Like if the key is down, that's when you should be turning right, and if the left key is down, you should be turning to the left. And whilst the key is down, that state will be engaged. As soon as you lift the key, the state goes off. So this is where we set up the states and actions. When you're binding a state, the first parameter, this, is to which input the particular state is bound, and you can have multiple inputs being redirected to different objects in the game. And for example, if I wanted to have an object that just managed the states for a particular aspect of my game, I can go and set this to be a different object, like an input controller. But in this case, this is all being handled by this game scene, which is this variable in this instance. So if we scroll down now, we'll find out, we'll look at the process method. Let's go down a little bit. So process is where typical game cycling occurs. And in the case of the turning left and turning right, it's as easy as just referencing the global input and then doing an isInput state. Again, checking for this against this as being the bound recipient of the input, and checking that this particular state is on. If it is, then we apply a physics turn. Same with the right hand. We apply a turn in the clockwise direction. So that's kind of the basics. If you're handling an action, it's not something that you're testing to see if the state is on or off. It's just going to be handled in the action handler. So once a particular input fires, like a key is pressed down, in this case I think toggling the music was one of them, pressing M, it will automatically call the onAction method with the action name that was specified, and for convenience it'll pass the event and position along with you to where the event occurred. So sometimes you can use that to dig a bit deeper into what kind of event occurred, or where it happened on the screen. So in this case, we look for the action name matching what we set, toggle music. So part of the reason that we have this difference between the input you have and the actual state name, the tag that it's given, is so that you can create lots of different kinds of input and handle that the exact same way. So toggling music is just toggling music. It doesn't matter if it was the D key or the M key, or you want to change that later, or if it's a particular switch that you press on the screen using a touchpad or an input. It's always going to end up becoming the same action that's handled, or the same state that's being handled inside the process. Okay, so that's the very basics of input. The Scrollia demo shows off a more complicated way of handling it. Actually, maybe I won't, more complicated to understand maybe, but I think simpler to code and manage. So let's have a look at the Scrollia demo. If you've seen this demo before, you'll notice some differences. To handle touch and the mouse input, just to demonstrate how this stuff works, we've added a few controls here. So I can press down on this with the mouse, and that'll cause that state to engage. I can press the cast button, and I can press the jump button. So, excuse my cough. If we go back, we can have a look at how those behaviors are added. And this is a little more sophisticated in that inside Scrollia, there's the create entity method, which I believe should be part of the entity factory. And when it creates the player, we actually add, instead of binding it using the PC device.input, this is going to be driven by an entity system. So what we do is naturally add a input component and attach that to the player entity. And in this case, you can list a whole range of states and a whole range of actions. And if you're wondering where this is processed, because that's all you have to do, you just add the states that you'd like and bind the inputs to those. Then they will automatically be passed whenever an interaction occurs to the corresponding system you added. So if we go back up, and let's have a look up here. Where is it? There's the game layer. Okay, so we've added to the game layer a system called player control system. And we go up here and find it somewhere. Alright, so here's the player control system. Now it's actually derived from pc.systems.input. And this, if you see how pc.device.input worked in the basic way, you can see how this is just a wrapping of how that process works to make things easier. So we attach the input component to the entity, and then this system is being driven out of the layer. So those actions are going to get called. Are there any actions defined there? I don't think there were. So this is it would call on action for this particular input control system. Otherwise, for the states, when the system gets its process method called for the particular entity which had an input control on it, and if you're not super familiar with how entity systems work, that's the key thing to understand, that because the system itself, this player control system, will have the process method called for every entity in the game layer that has the input component added to it. So in this case, we've only added the input component to the player entity. So I know that the only thing being handled by the player control system, hence it being called the player control system, is going to be the player itself. That's the only entity that's going to come in here. But if you're thinking about how to handle input from multiple entities, all of which having different input components, then simply jumping in here and saying if the entity has a tag. So, excuse my bad typing day. Then do something different. Or it could be I want to handle input for a particular tower in a tower defense game. So in this case, the processing of the states is handled. We know that it's the player, so we're going to get his brain out. and then test whether he's casting, whether he's attacking or moving or walking or whatever, and handle those states appropriately. So you'll notice that this is handling, if I go back to this original code, down here, so all these states are bound to particular keys. So you'll notice in the Scrollia demo, these are actually input components that, they're shapes that have been added to the UI layer. They're not even part of the game layer. As I touch them, the player's being moved around. So how do we do that? If we go back over to the code, and this is something that's only changed in 0.5.3 to demo this. Inside the game scene constructor, you'll see new sections here, and we'll look at particularly the left arrow here. So this is going to create an entity. It's going to set its spatial as essentially positioning it on the left of the screen, and it's positioned at the bottom of the viewport, i.e. the viewport height minus h, which is the height of the component I wanted to create. And the width and height are set there. Then it constructs poly, which is another new component that we added in 0.5.3, and it has a line color. You notice it's a nice bright red. And the reason that, if we look back here, you'll see that it has that nice little shading effect. That's actually created because an alpha component was added, setting its level to 0.2. So it's only showing 20% of that, and that's why you get that kind of nice bleeding completely by accident. I went, oh, that's cool, and kept that. So that's a spatial, a poly to draw. Has a big fat line width to create that effect. The alpha component, and then the new interesting thing is the input component. So two things to notice here. The first is it specifies states, and it indicates that what state is going to be set once this input is triggered is moving left. And the two things that can trigger it are a touch event and a mouse left event. And you'll notice that the true here, which I think is the default, I'd have to check. The true means that the state or the action can only occur if the input, in this case a positional input from touch, is within the bounds of the spatial. So that means if you want to have, for example, I touch anywhere on the screen and he'll start moving left, then I'd set that to false. Otherwise, if this component is added to an entity that has a spatial associated with it, then it's going to assume that any positional input you have is just always going to be bound to only be allowed to occur within the bounds of the entity. So that's a really nice way to effectively create this idea that as I move my mouse over, if I'm clicking on this, it's only going to have an impact. It's only going to trigger the input state or the action if it's within the bounds of this particular spatial. In this case, I think we were looking at the left arrow. It's going to be that rectangle around there. So if I click up here, it'll trigger it as well. Okay, let's jump back. So the other interesting thing here is you notice that this was added to the UI layer. It wasn't added to the game layer. And the second thing is that the input for this particular entity, which is the left arrow, is not going to the left arrow entity, or it's not going to a control system. It's being redirected to the player. And so what's happening is when the state is detected, the action or the state that is being changed when I touch on the arrow is actually being kind of faked into the messaging being sent over to the target in this case, which is the player, which is over on another layer driven by another system. So we jump through some hoops to make all that kind of simple, but it allows you to do this really easy case of, I just want to stick controls everywhere on the screen, and when you do this kind of thing, just make that state or action occur over on that particular object, even if it's across a different layer. And that way you get this really nice case where you've got, I want to have touch and mouse left on the arrow, the left-hand arrow, set the state on the player for moving left. And it creates this really clean way of doing it. If you look at the right arrow, again, moving right is the state that's set, target is the player. In the jump button, similar thing. In this case, it's a circle. You notice circle is another new component that we just added. It's dead simple to use. It works just like everything else. So in this case, the target is the player. When they click on the jump, then it's going to generate the jumping state. Here's another good example of a state. If I just hold my mouse down, he's going to keep jumping because he's in the jumping state. He's not generating a jump action. And that's a good example of the difference between an action and a state. If you want him to just keep jumping as I hold it down, then you're going to want to use a state, not an action. And then the last one is the casting, which is where we can spray some fireballs. Okay, one of the nice trick that we added here was that when you're holding the mouse down or you're holding touch down, we were actively tracking those states, and we have to do that to handle a case where you're holding the mouse down, and I have the mouse down now, and as I move into something, it's tracking that it's being hit, and it's going to generate the state. And then as I move across to other objects, it's going to transition out of some. And this will even work if you're laying entities on top of each other. The reason you need this is that people don't much care about holding a mouse down. They might do that, but it's really apparent when you're working on a touch display and you're playing an iPad game or an iPhone game, and people tend to be sliding their fingers across stuff. So your thumb will tend to be down the left, you'll slide across to the right. And without this, the touch controls just won't feel natural. Let's see. I think that about covers everything. So the new stuff in 0.53 was the circle component. We've made some changes to the rectangle component as well, just handles stroking better, a little bit more cleaned up. Don't forget you can do rounded rectangles in there if you haven't played with that, it's cool. We've added a poly component so you can just do arbitrary drawing of convex shapes. We've added new input component with support there, and then we've added some extra stuff to the Scrollier demo to show off how it all works. Okay, that's it. Thank you very much.